we need to sketch the graph of an example function f that satisfies these conditions. Let's go by one. So first, f at 0 equals 0. That means the function, the graph passes through 0, 0. That's the origin here. Okay, this is done. Next, the function goes to infinity when x goes to -1 from left. So whenever function goes to infinity or negative infinity, when x goes to some number, that means we have a vertical asymptote. So here a vertical asymptote is x equals -1. So -1 is here, so we have a vertical asymptote. So I'm just writing dashed lines, and we know that when x goes to -1 from left side, the function goes to positive infinity. So from left goes to positive infinity. So I'm just gonna mark this for now. Okay, I don't know what happens here, but when x is very close to -1 from left, the function goes to positive infinity. And the second, the function goes to negative infinity when x goes to -1 from right side. Same thing, same information. Vertical asymptote at x equals -1. Function goes to negative infinity. So down here, so I'm gonna make this graph, just portion of this graph. I don't know what happens here, but when x is very close to -1 from right side, the function decreases without bound. So this is done. Next, the function goes to function goes to negative infinity. That means function decreases without bound when x goes to x goes to 1 from left side. This is same thing like earlier. When the function goes to positive infinity or negative infinity, when x goes to some number, so we get vertical asymptote. Another vertical asymptote here is x equals 1. So at 1 we have another, sorry, it should be straight dashed lines. Okay, that's the vertical asymptote. So let me erase some of these. This is, and when x goes to 1 from left side, the function goes to negative infinity. So from left side goes to negative infinity, decreases without bound. Okay, look at here, this is done. And this one, when x goes to 1 from right side, put the same, the function goes to positive infinity. So here, okay, up going to infinity. This is done. Now when x goes to infinity, when x is very big, the function goes to 1. So we got a horizontal asymptote, HA. On the right side, y equals 1. So here is 1. So we have HA, horizontal asymptote, and then function goes to 1. Okay, so the graph can come from the top and become closer to 1. Okay, or from bottom, but we have already this portion, so this will be the case, being very close to this line eventually, and we have this, so we can just connect these two parts. Okay, that's one part. This is done. So we have one horizontal asymptote, y equals 1, and here we can have the same information. Okay, the last here, the function goes to -2 when x goes to negative infinity. When x goes to negative infinity, so here x going to negative infinity, the function going to -2. That means horizontal asymptote y equals -2. So here, okay, so the graph can go from bottom or from top, but we have this already there, so just bring this something like this. Okay, try to make it curved, not like a straight line here. Okay, and that satisfies everything, but we can connect. Look, the graph goes from here, and we have these two things, x going to -1, from right or 1 from left going to infinity, we can connect these two, this part, and make a curve, not a corner, like this. A nice curve, okay, smooth curve, and this. So here is a graph. You can make it even smoother. Okay, I mean, there can be infinitely many correct answers, by the way. Okay, this is one example. Final